Good morning, ladies and gentlemen. Welcome to this session. The times they are a-changing. I thought I would take that cue from Bob Dylan, one of my favorite poets and singers. What we are trying to do is to change the playing field that you're working on. There is much richness to be had in Bob Dylan's lyrics. From don't stand in the doorway and block up the hall. I guess we don't have that problem right here today. But the times certainly are a-changing, and your old road is rapidly aging. You can't lend your hand for the times they are a-changing. Indeed, I hope that when you leave this presentation, you will get a glimpse of how we're trying to do that. So, my name is Peter Willits, and I'm a senior program manager for Microsoft. I am responsible for the X++ language and its implementation. My team deals with the whole X++ stack, the compiler, the debugger, the runtime system, and all those parts. And also now we have been chartered with the .NET integration story, where we have built with a lot of other very talented teams across the world, the story that you are about to see here today. So, I guess this is the, third day of Convergence. So you've seen these before, so I won't go into them. We have to have them here for the legal aspects. In the slide deck, you will find the complete disclaimer after this slide, but it's a hidden slide. Also, these bits are not released to manufacture bits. We may see some problems. I hope we don't. But if we do, rest assured that these are not the bits that the customers will see. So, before I go any further, I would like to sort of streamline my messaging a little bit to the people in here. So, first of all, who are the nerds in here? Who are the guys who are not intimidated by code? Excellent, excellent. And then who are the business personas, the management guys, the people who make the decisions? That's far fewer. All right, so I think it's fair to be a little more technical in the presentation that we're doing here. So let me go over the pains and challenges that we have tried to address with this release. So the personas for those are Isaac, the top gentleman there, who's an application developer, a hardcore guy. There's Nandita, who is a customizing sort of persona. And Isaac was concerned that business logic development in .NET was far too difficult in AX 2009. There was really not a very clean story about how to go from types in X++ to types in .NET and vice versa. The interop story was there. For many scenarios it worked, but it was difficult. There was too much you had to do by hand. You could not manage transaction scopes, identities, all that stuff from between the two worlds. That was painful. And even in some situations, you got into situations where X++ performance was not what you wanted it to be. Even though I would, of course, argue that those would be pathological situations that you should never get into, but our customers actually got into those situations. For Nandita, we have situations where the total cost of ownership is too high when you're making customizations. What happens typically is that we ship something, people take a snapshot of the code that we shipped, make modifications to that in their own layer, and that'll work perfectly, except when they need to upgrade, the carpet will be swept away under them, and potentially they will have to figure out the same customizations all over again, which is a painful thing. The model that I just described is not all bad. It has a lot of virtues as well, and I'll go into that a little later, but that was mainly the pain and the challenge that Nandita persona here experienced. So, how are we addressing those? How have we fixed those? Well, this is sort of the agenda for the presentation as we go forward. We want to explain to you how you can use .NET to a greater extent than you have been able to before. We will be showing you some changes that we have made to the X++ language semantics. And we will briefly discuss how this will impact you, because unfortunately there is an impact to you. We tried to minimize it, but we have not been able to remove it. We will show you some of the other benefits that we can provide with the .NET integration. So we have aired this to others as we went along, and I want to show you some feedback that we received from a partner in Iceland. So let me just only a few seconds.
There's a whole lot of developers that know how to work Visual Studio that may not know how to use the AX development tools. So I think that's going to be very helpful, and it will allow us to share resources more efficiently, and obviously there will be a bigger pool of developers that we can recruit from.
So this was Petur from To Increase that you can find in the expo hall. Go talk to him. I don't know if he actually knows that we put in this slide about him, but there it is. So let's continue here. So where are we in the stack that we're talking about? Well, basically we're at the bottom level. We are at the framework level, so the stuff in blue that you see at the bottom of the screen. We are the people interacting between the tools and the technology stack below. So we deal with language services, obviously. We have the integration with Visual Studio, the design tools that you haven't seen yet maybe, but I'll show you later. We deal with the programming models and frameworks that we support, and some other stuff that we've termed batch services, but we own a few other bits and pieces as well. So let me just grab my laser pen, because I think I'll be needing it. All right. Okay, so let's go with the first set of demos we have, which is about the X++ language enhancements. Later, we're going to do another set, which is about authoring business logic in C#. And then we're going to show what I consider the jewel of the crown, which is how we can generate common intermediate language from X++. Now, I'll be referring to the term common intermediate language, or IL, or CIL, quite a bit through this session. So can I see hands for who don't know what that is? A few of you. All right. So I'll take 5 seconds to explain this. Whenever a managed compiler compiles into managed code, it takes the, say, C# code and compiles it into an intermediate language that is then executed almost by the hardware of the machine. So that's sort of an abstract representation of the program being compiled. That's what we call common intermediate language. We'll get to that a little later, but let's move on. So what did we do? Well, we did a lot of stuff. We provided some Visual Studio tools that allow us to do some development from Visual Studio. Really cool. We provided some very, very strong infrastructure that I'll show you. This is sort of the plumbing or the glue that allows you to work seamlessly between the two worlds of X++ and .NET. This is what used to be called the business connector. We've added attributes to the X++ language as a very general programming paradigm. We provided events, which is also something that you'll know from .NET, obviously. We fixed some language issues. And we made X++ into a managed language. Okay, I'm going to say this again. We made X++ into a managed language. Thank you. Okay. So let me go through some of the changes that we did to the syntax and semantics of X++ language. So method visibility rules have changed. A method can now no longer become less visible than its parent. This is something that you should be well aware of. This is the case in .NET, and this is now the case in our system. We know that many of you have not been very diligent about putting private, protected, and public on the methods where you need them. But guess what? This is now enforced by the compiler. So this gives you a nice opportunity to clean up your code a little bit there. The rules that were in effect for abstract classes and interfaces were very, very messy. We have changed them so that they now conform with .NET, which means that if you have an abstract class, as a base class obviously, and you have a non-abstract class that derives from it, then all the abstract methods on the abstract class need to be implemented in each non-abstract derived class, which is sort of many of you are nodding and say, yes, of course, I mean, that's what I would expect, but that was not the case previously. Previously, they were far more complex rules. And we had to change this because of our integration with .NET. So there's not a lot we could do. This is the more interesting one, the more painful one. Rules for overriding are much stricter now than they used to be. And this is because we needed to conform with the .NET runtime system that enforces these things. And we also wanted to remove a whole class of runtime errors that were there before, that we have now fixed. So I'm going to show you in a few minutes, or next few slides, how that works. I think you will agree that it's a cleanup, but it may cause you some rewriting, I'm afraid. We also provided in the language support for table inheritance. So I'm sure some of you saw the presentation, was it yesterday? Yes, yesterday, that Adrian Ort and CV did. And he went into how these tables can be represented in hierarchies now. If you look at my little insert here, you'll see that it's very small, but we have a party table up there, and from that we derive a person there, and an organization, and an organization can be further specialized into a non-profit and a government organization. So this is the sort of breakdown that you would expect to take place in classes. But that whole system now works for tables as well. A particular table can now extend another table. And the set of fields that are available on the derived class, I almost said, the derived table, is the union of fields from all the parents. And the method, polymorphism, and all that works as you expect. So that's a change to the semantics of the language, and indeed a huge change in our whole stack. It's just surfacing a little bit here in the language. Now let me touch upon some key concepts. Attributes, because there's something that we added in the language as well, which is a conceptually very useful thing for you. So attributes are a system that allow you to provide metadata to actual code. So you can take any class or a method and apply an attribute to it, expressing some knowledge or some fact about this particular piece of code. And there are then APIs that are able to reflect upon this and make decisions based on that. This is exactly the same concept that you know from .NET. We even took the syntax from there, and much of the semantics is lifted directly from .NET. So people who know about this should not have big trouble understanding it. It turns out that this was a very, very fortunate investment that we made into the language, because it is already now being leveraged in lots of different scenarios. I'm sure that you have by now heard the services story that we have, where we can take any class and then we put a sys entry point attribute on it, and on each method that we want to expose, we put a data operation or something, I don't remember exactly what it was called, attribute on there, and then through some drag and drop, suddenly those will be available from you, or to you from anywhere using a service call. So we use that to actually generate the WSDL that's then consumed by Visual Studio and other tools and so on. That's just one use. We have other uses as well. Delegates are two things. They're both a programming concept that you can use in your normal development, but they're also this very, very useful customization vehicle that allows you to do non-intrusive customizations. So before, the only customization story we had was this: copy the source code and do whatever you want and take the consequences. Now we have a slightly or much less intrusive story where we say these are the hook points. Now you go ahead and add whatever you want to those hook points. But the guy who's exposing the hook points, the publisher of information, has no idea and is not touched because of this, will not appear to have been changed just because you add handlers to it. So let's look at this overriding problem for just a few seconds. So what we had before was this. It was perfectly legal. So you had your base class here. You have some method f that takes a common, which, as you know, is the base class for all tables, and it did something. Then you have a derived class that extends the base class, and then you have the same method f, right? So this is an override, and you take a sales table. Now, of course, sales table is derived from common, So the old compiler, the 2009 compiler, would not object to this. The only requirement was that the parameters needed to be derivable from one another for this to work. But then let's consider the example down here. So we have a cost table, which is not a sales table, of course. And you have a class that you instantiate, this derived thing, and then you call with the cost table. Now, what do you think happens in that case? It works? So when I call f, which f do I call? This one or this one? The derived one? So what's the value of st then? Exactly right. That's exactly right. And that's what compiler writers, like myself, dread the most, is situations where the compiler can't catch this very important whole range of problems for you that should be able to be resolved at compile time. But we're not. We're saying, let the testers figure it out. But that's not good enough, right? So let's see how we solve this. We have the same base, and etc. But now you're not allowed to add anything that is derived. You have to add common here. You have to use that type for the parameter. And then things work perfectly. Then you can use the as thing here to reliably check whether the argument is a sales table or a cost table or whatever it is. So that's the sort of the paradigm that you need to use from now on. And I know from bitter experience that there's going to be a lot of code that does this. In our code base of 5 million lines, we spent a few weeks fixing this up. So you may have situations where when you compile with a new compiler, you will get into this situation. So you have to change the class hierarchies, the parameters, to conform to their parents, which is, by the way, the case in .NET. And this is not just something I'm saying because like it's a coincidence, because of course that was our driving factor. The runtime system of .NET will simply not allow the case that I showed you before. No. In this case, you will be passing the cost table, and then this expression here, st as sales table, will return null because st is not a sales table. So we introduced two new operators. One was the as, and one is. So as will return the instance or null, and is will return a Boolean yes or no, whether it's of that particular type or a derived type. Excuse me? I'm sorry, I don't understand. Yes, it does. So the question was, I'm sorry for the recording, whether this replaces sort of things that you did with table ID. And yes, we don't use that anymore. We like this much more. It's a much cleaner approach. Okay, so let me show how this works instead of just talking about it. So let me take the attributes one first. So let's take a simple example where somebody is, a vendor is writing code for you. And let's say that this vendor was paid by how many methods and lines of code and so on that vendor wrote. So we would like to introduce an author attribute that you could decorate classes and tables with and say, I'm the author of this. So the only thing that you need to do, and I'll magnify this, I promise. So let me use this cool new feature down here. Oh, it's so cool. Let's do it once more. There. Okay, so how come I can do this now? Well, that's because we're using the Visual Studio editor now, not our own editor. We lifted the Visual Studio editor into our product, so it can do all sorts of goodness now. One of the goodnesses is that it can actually do what I just showed you. It can also write in italic and color code and do lots of good stuff. Anyway, an attribute is any class that derives from sysattribute. In this case, the state that I want to persist is just the author. So that's just a string. So the only thing we need to do is to create a constructor for that. Of course, we haven't really wired it up so it always does this. which we should. But anyway. And we just pass it the author, and that's it. And then we have a .author here that will return that particular author. And that's it. That's all we need to do. So then let's say we have let's say we have the quicksort algorithm. I'm going to try my new toy now and see how it works. Nope, that didn't work. It was because I pressed the wrong key. Control 1. So here we are using the name of Charles Anthony Richard Hoare, who was the inventor of the quicksort algorithm 30 years ago. So we're taking the author attribute and applying that. There's some other, oops. There's another method here, which is written by John Doe, as you can see, which is not particularly interesting. But the point is that you can now gather code statistics. You can write a piece of code that actually goes ahead and reasons about this. So I'm just going to run this. And you'll see that the author, Charles Anthony Richard Hoare, wrote vendor class.quicksort, which is 38 lines long, but only 20 lines of those actually have any code on them. The rest are blank lines and comments and stuff like that. And John Doe wrote this other sum method thing that only has these statistics. Notice how we're using now the ability of X++ to reason about itself using these attributes. And as I said, this is what we use for other purposes as well throughout the framework. I want to show just one more. It's not something that I want to dwell a lot on. But let's say that we have an old API. Here, class old API. And we have my deprecated method here, which we really don't want to use anymore. So what we can do is we can apply the sys obsolete attribute, like so. God, this is more pain than it's worth. So now that we have applied that, then if we try to use that particular API and call a method on it, you will see that the compiler will actually say that this method is obsolete. So we have made one small integration as a proof of concept more than anything else, so that when you apply the obsolete attribute to something, then every time you use that particular method or class, then you will get a message that this is obsolete and you should use something else. And you can provide text in there that says, don't use this, use that instead. And that will appear in the error message here as well. So that's just one more application of attributes. As I said, the main application now is for services. Do I have one here? I guess I do. Let me just check what this is. What? Okay. This is this entry point attribute applied. Okay, let me go now briefly to the next great thing, which is events. And we're going to start with the publisher here. I'm going to try to do there. So we have a publisher. It publishes some sort of information. And let's say that this is something that can add a customer from a legacy system, say that it reads an XML file, does some munging, and so on. And the authors of this were very wise because they foresaw that somewhere along the line, somebody might be interested in knowing about which customers were being added to the system. So they provided a delegate for that. And the delegate is this customer created guy down here. So this is a delegate. As you see, it uses the keyword delegate. And it has a particular parameter profile, which is the age and name. And then the publisher, for his part, will actually call this as if it were a method call. And the mail mine being what it is, I add Penelope Cruz here, but you get the message, right? Anytime you read this XML file for each customer, you would just add that particular data. That's all fine. So if we don't have anyone interested in this, this is a null operation. Nothing happens. But, of course, we want to see how this is used in practice. So let's say that we have a subscriber, somebody who's really interested in knowing about this. And say that we had a method that wants to know. What we can do here is we can take this guy here and drop it onto there. There. Now you'll see, let me see if I can. Now you'll see that we have an event handler underneath the delegate. And you can have any number of those, of course. And I'm going to show you the properties for this over here. There. I don't know if I'm going to continue doing this because it gives me the creeps every time I do it. So this is an event handler, which the class is subscriber and the method is myStaticHandler. And of course, the type is X++. And this is important because you can do events in managed code as well. What you need to do there then is give a full name with namespace and class name and so on. And then the system will figure out to actually call managed code to handle that particular event, which is something that we'll show a little later. But that's not all, of course. Let me just save this. There's also another way you can do this. You can add pre- and post handlers to any particular method. Let me take a pre thing here and drag it onto, say, this guy down here. Now you'll notice that even the method, let me fix. God, I hope this works. Now the method actually has underneath it a partly obscured handler, and we can, in the property sheet for that, we can say whether this is a pre-handler or a post-handler, right? So those were the two main uses of this. I want to show you this particular piece of code, this snippet here, which is what people have been asking the 2 days that we have had this. Can you do this in code as well? And certainly you can. We have the plus equals and the minus equals expression or operator that allows you to do this at runtime. So you could have a piece of code that initializes itself by attaching to all sorts of interesting places, and then it would run, and that would be it. You don't have to express this in the model. You can do it through these operators as well. Okay. Right. I could run this and so on, but I trust that you will believe me that it works. So I just want to show you one more thing that has never been shown before. So this is always a little risky. But as I just told you about these table features where you can derive tables from one another and you can have relationships that in interesting ways relate to other tables so that you can normalize your tables, remove redundancy, and so on. But the input that we got was that this would be difficult to debug and to work with because you would not be able to see. You just have a rec ID, some 64-bit number that would point to some other field somewhere else. And you would really not, when debugging, know what you were referring to. So what we did was we did a little tweak to the debugger. I can't make this larger, I'm afraid. Oh, maybe I can. It's not going to do me any good. Anyway, we're referring here to the party field. And party is really a reference into a dir party table. Now, normally you would just know that this is some big number, which is, in this case, well, 5, 6, 7, blah, 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 etc., which is not very useful to you. But now we actually go ahead and find the interesting information from that particular record and display it, which is name, which is light and demo. So this is a much, much, much easier way to debug now. You can immediately see what references point to in your database. So this should be a huge benefit for you when you do your debugging. So we're quite proud of that. Thank you. Okay, let's get rid of this guy. And back to the presentation. All right. All right. So now, going forward now with some Really important stuff about how you can build business logic in .NET. So we've improved that story a lot. It is now possible to seamlessly, this was not the case before, you can seamlessly now refer to X++ objects from managed code. We have a great story there. We have a tooling experience, and we have a runtime experience and an authoring experience that is very, very good. And the main difference here is, apart from the tooling, at runtime we have a situation where the managed code that you're now running runs in the same sandbox, so to speak, as the X++ code did. So it runs within the same user context. You have the same privileges as the user you are. It knows about the transaction scopes that were established in X++. All this is one and the same sandbox. You're not going out into some environment over here, doing stuff, and then coming back in, and you don't have a clue about what happened here. These are not disparate environments anymore. They're the same environment. That's the real magic here. So in order to do this, we provide what we call proxies that give us access to tables and classes and enumerations from X++, so that we can refer to them just as if they were managed artifacts. What do I mean just like they were? They are managed artifacts. I mean, we're not doing make-believe here. They are managed artifacts. You can refer to them, not in this thing that I have on my box, but ultimately you'll even be able to consume the documentation comments from managed code that the user put into X++. That's the extent of the integration that we have. So we have that story. I'll show you in just a few minutes. We also have what we call the new business connector, which provides this very, very rich interaction between the two environments. This is not your grandmother's business connector. This is a new business connector that only contains about 5 to 10% of the code that was in the old one. It's completely rewritten to provide the functionality that I'm going to show you in a few seconds. And the Visual Studio, of course, integration provides this great design time experience so you don't have to mess around too much. So, the tooling inside Visual Studio allows very, very simple gestures to establish this connection between the two environments. I'll show you it a little later, but let me just illustrate here. In Visual Studio, we actually can show the AOT now, the Application Explorer, as we call it in Visual Studio. And over there, you have your project. And it's as simple as dragging a class or a table from one side of the screen onto the next. Then you're done. That's it. You've created yourself a proxy. Simple as that. That's all you need to do. Now, somebody's going to say, yeah, right, okay, well, we've been in this situation before. We hand-coded our proxies before, but guess what? They became stale because somebody else, added a few methods that we need or changed a parameter profile, and now I suddenly get runtime errors and all that. It doesn't work. Guess what? It does. Because now every time you do a build, you actually go into AX and refresh these proxies and regenerate them. So you will never get in a situation where you have a stale proxy that does not represent exactly what you have in AX. So this is a powerful story, and it doesn't add any overhead. Now, the runtime architecture. I'm going through the theory first, and then I'll show you in practice. The first call we make from the yellow guy over here, the kernel, into the .NET world will establish the connection between the two. And these calls go through the bc.net, which is your new bc.net. And then that bc.net manages subsequent calls going either way. And this layer that we have in the middle here, over here, this guy, allows us to do something we call object idempotency, which means that an object you have in X++ can represent an object that we have in C# and vice versa. So if I have something here, I modify the state, I call out into managed code, and I modify the state again. Then when you get back to your X++, guess what? The state is modified. These are not two different objects that we're talking about here. They are one and the same. So hence the term object idempotency. Patent pending. So I wanted to show you this picture because it has a deeper connotation that you would think. So the new bc.net, the blue guy up here, really is part of these down here. Previously, the business connector was sort of a standalone thing, its own kernel, that lived its life without a front end. There was no face to it. That's not the case anymore. Now the business connector is actually attached in the same process space as the client or the server, or we even supply the situation where you can use the bc.net without actually coming from a client or a server situation. We still support that. We don't recommend it. We recommend services for many of the usage that we would otherwise use that, but we still do support it. Okay. Let's go. Let's do this. So, demo 2. So I'm going to show you a piece of code that is going to seem very, very silly almost to you until you understand exactly the implications. So I have here a piece of code that, as you can see, it has a managed namespace here, open form class, and it instantiates a new one of those. So this is opener is a managed object. And then you do open form and give it a name of the form that you want to open. All right? Let's see how this works. It opened the form. Wow. What's so... I mean, I could have opened the form 10 million other ways, right? But consider the implications of this. And the implications will be easier to understand once I show you the managed code. So I'm going to open my Visual Studio environment with that particular piece of code. There. And I can use my little trick again here, because it is the same editor after all. So what I'm doing here is I'm doing new args, I'm setting the form name, I'm instantiating myself a form run, and then I'm calling run on that particular thing. Now, do any of you recognize this code? Yes, you do. Good. I'm so glad. No, so this is exactly the code that you would write in X++. This is exactly the same code. But now it's being executed in managed code. In the old days, you would never be able to do this because the business connector that provided you access from managed code was completely faceless. Now we are integrated in the same process space as the client. In fact, we are part of the client when we do this. So let me show you the debugging, how you would debug this. This is really cool. So attach to process, attach to the client process running, load some symbols and so on, and let me go back to my guy here and run this. Wow, the Visual Studio debugger started up. And you can debug this now as you would expect to do, right? I mean, you're using Visual Studio here completely seamlessly. Now, some of you, just to hammer the point home a little bit here, you see references to args here, and you know that you're thinking args is a class that we have in X++. So they must have a proxy for it. And that's exactly right. So if we go in, and let's just finish this. So if you hover over this args thing and do a go to definition, you will see the code that we would normally hide. But of course, I'm not a big hider, so I'm going to show you anyway. So this is the code that was actually generated for you behind the scenes when somebody dragged the args onto the solution. You're not supposed to see this at all, of course. This is something that you would never mess with because it would be regenerated behind your back whenever you change something in AX. What does this remind you of? This proxy story has a very, very close connection to something else that you know intimately. web services. It's exactly the same story as you had for web services. Exactly the same. Okay, so let me go back, excuse me, to here. And let me show you the, in fact, let me just detach from this guy first. There. Let me show you the Application Explorer. There. Pin that guy. There. So, as I alluded to before, it's really as simple as what I'm going to do now. I'm going to take a class. Let's take something random like the, I don't know what this is, but I don't care. I'm just going to take it. Okay. So now here, I'm just going to show this other thing first. Now you see this ACC blah, blah, blah as an artifact in the solution. So you'll know that you can use that. And all the dependencies that this has, there will also be generated proxies for those. So if this class has methods that use other types, then those proxies will transitively be generated as well. So you have the full environment. You don't have to think about that yourself. We do that analysis for you to generate the transitive closure. And now you can just use your, go ahead and knock yourself out with the ACC dist rule product tags. You see it immediately appears in the IntelliSense, right? And all the methods are here as you would expect, with the parameter types that you would expect and all that. It really is a very, very strong story. I hope I'm doing it justice so that you understand the deep implications of this. No, so the question here was, for the recording, the question was, so now if I go in and I actually change or add a method or delete a method or change a parameter profile or do something else, do I have to regenerate these? And the answer is no, because we have built into the build step of projects like this that it automatically refreshes the proxies for you. So as soon as you make a change, the proxies will be refreshed, and you will catch at compile time any errors that ensue from the changes in the X++ API. So no, you do not have to, again, know that something changed and then go in and, no. So in this case, it's a better story than the services story we have. Okay. So I have another demo that I'm going to show. I'm not sure it's a very compelling demo, just like the last one, but we'll see. Let's say that we have an X++ class called Common Class. I'm going to do this quickly because we're running out of time. We have an X++ class called Common Class, and it has some state in it. And I'm going to set the state, which happens to be a string, to be X++ on the client. Now, I'm just going to print it out so everyone can see what it is. And then I'm going to call a method on my some managed code that I wrote where I pass this particular object that I showed you before. And the managed code will actually set the state to something else. It'll set the state to from managed code. And then I'm going to print out the string again. So I create an object, I set the state from X++, and I pass the object to somewhere else, to managed code. The managed code makes a change. But magically, when I return from this call, the state is actually updated on the object. So, you know, it's the age-old question, is light a particle or is it a wave? Well, it depends on how you see it, right? It's the object idempotency at play. So I don't have a phone with me. Okay, let's try this. So it said X++ on client and then message from .NET. And for the sake of completeness, of course, I will show you this particular thing. Oops. So you see, this managed code just sets the state of that particular object. So it's no big deal. But the key point to take away here is that from .NET, so the X++ and the managed code, they work on the same object, even though the representation is .NET.
So can I take something with a what, or in my intermediate window, take the value of it now?
Yes? Yes and no. If you step into it, you will be stepping into the proxy. And then there's nothing that will, that's a good question. Whether you will actually start up if you have set the debugger to break on breakpoints from the business connector, then yes, I think you would, at least if you have a breakpoint in the X++ code, the debugger will open, the X++ debugger will open. I think if I have a little time, I'll try to repro it for you afterwards. It's a good question. Sorry. Yeah. So that is so the question here is, how does the developer know what is what? What is happening in X++ and what is happening in .NET, and what's the story there? And the story is that in the AOT, right here, we have a node called Visual Studio Projects, as you see right here. And in there you can have your C# projects, your VB projects, whatever it is. And these are subject to search, just like anything else. So you can search there. And the cross-reference is also updated. So the cross-reference system that we have, which is a system that says this method in X++ calls these guys and so on, that'll include the calls to managed code as well. And the managed code's calls through proxies back into the system. So that cross-reference link is still there. So that's the main tool that you would consume to understand that dependency. Now I have to move on, so let me, because now we're getting to something really, really, really interesting. Okay, generating CIL from X++. We made X++ a managed language. The story right now is for code running on the server only, because we thought that's where the heavy lifting takes place. That's the natural place to use this. So right now, the system will allow you to run code in IL from X++ that are services or batch jobs, or when you say in X++ that you want to call this method in managed code. So all three of these possibilities are there. So somebody's going to say, well, you know, does that mean that you're not really compiling all the code into CIL? No. All the code, all the 5 million lines of application code that we have pass through our builder that builds intermediate language code. So anywhere, any class, any table, you will be able to execute in IL from within X++, or from a service, or from a batch job. So just to recap, CIL, Common Intermediate Language, is what's run when you run a managed application. Of course, the gurus in the room will tell you that that's not exactly true. Do we have a guru here? Someone? Tell us why this is not true? Okay, I'll fill you in. It's because at runtime what happens is that the system will load the DLL and then it'll do just-in-time compilation, which takes the CIL code and compiles it into the native code of the processor upon which it's running. But you know, I didn't want to cloud the issue, and I guess I just did. So never mind. Okay, so the X++ compiler, the native X++ compiler, generates P code that's executed by a proprietary interpreter, the interpreter that we have always known, and debugged by the legacy debugger that I've showed you before. That story remains. Yeah. So we did a little experimentation. This was very early. So I'm not sure that these numbers still hold, but they certainly did hold at one point. We had a situation where we were doing posting of a journal. This was a huge journal with 90,000 lines in it and all sorts of other complicating factors. And it took about 25 hours to run in X++. When we switched over and said, let's try to do this in IL, it took half an hour. So this was the first time that we got some sort of indication that there was some reason to what we're doing here. This was a pathological case, and this was not coded very intelligently in the first place. So your mileage will vary about how much performance benefit you gain. But this was what led us on to say, maybe we can productize this. Let me show you another situation. Let's say that you have objects that have interdependencies. So I have an object here on the client that refers to an object on the server, and this guy refers back to the client, which means there's a loop. Let's say that we make, instead of 1, we make that 500. So there are 500 objects, and the last object points back to the first one. Right? So there's a loop with 500 elements in it. If I create that and destroy it again, then I don't incur any time. But if I go up there, let's say I make that 11,000, then I'm consuming about 5 seconds just for the work of maintaining the information about the loops. We have something we call deterministic garbage collection in AX, and that takes a little time in this particular pathological case. The problem with this is that it does not scale very well. It scales extremely poorly. As we get into 500,000 territory, we're up to 50 seconds, and we go through the roof up here when we move further along. This is a known issue about X++. I've been standing on my soapbox for decades almost, explaining about this particular thing. So we thought, okay, let's do that in .NET. And what we saw was this. This is not just the color of the axis. This is the generated data that we have here. 0. It is not measurable. So in situations where you have these object loops, then you will benefit from the non-deterministic garbage collection that .NET features. So I want to show you a little bit about how this works. So the X++ compiler takes the code in there and some stored in the metadata, reads that, and it produces P code. So what we did was we said, okay, let's see what we can do. This P code here looks suspiciously like IL code in some respects. Technically speaking, they're both stack machines, abstract stack machines. They have sort of similar constructs. Let's see if we can marry those two. Let's see if we can do something intelligent. So what we do then is that we, apart from the P code, we also generate some XML that you're not supposed to look at. And then we have a CIL generator written in managed code that spits out PDB files and assemblies, DLL files. So that's how it works. So you will notice that this part up here, which is the traditional story, did not change. And this was one clear point that management gave us. They said, okay, you can go along on your managed adventure, but you cannot modify the X++ compiler significantly because we have 15 years of test and millions and millions and millions of lines of code out there that we don't want to break. So you cannot rewrite the X++ compiler. But that's not what we did. We took what the compiler generates as our starting artifact, and then we generate the PDBs and assemblies from there. That's how it works. So the architecture in the X++ runtime, we have our source code, we have our compiler, we have our X++ P code, and then we interpret that, and we call these unmanaged built-in functions and the unmanaged kernel. That's sort of the interaction that takes place between these two. In the new environment, we have the same thing, compiler, P code, but then we have this IL generator, CIL generator, that generates an assembly that is executed by the .NET CLR that then talks to these two when necessary. That's the new runtime architecture that .NET features. So the system is now able to generate IL code for your whole application base, all your classes and all your tables, but you do need a 64-bit machine for it. And you do need some good RAM in there to do this. You should be running on, I wouldn't say high performance. Today it's more like normal performance 64-bit machines. I'm sure your developers already have 64-bit machines. I'm sure they'll be fine. It takes us, hang on, it takes us 8 minutes to compile all our P code into IL code. I'll get back to you later. So let me show you how that works. So I'm going to take the Towers of Hanoi that you all know, right? There's no computer science textbook in the world that doesn't deal with the Towers of Hanoi. Correct? Correct. The other one is the factorial numbers, but they're just so primitive that I didn't want to use them. So what I did here is in my main thing, I determined the number of disks. The number of disks, which in this case is 10. And then I run the algorithm in the interpreter first, and I make sure that I call get tick count to get some indication of how long this takes. And then I run this in CIL, and I can show you the gunk that makes this happen, but it doesn't matter. Just trust me that this is running in IO when I get there. And I do a similar get tick count calls there, so I can see how long this takes. And then I show you the actual results afterwards. So let's see how that works. That was quick. So, wow. So it's not easy to see, but it says 1616 units. I'm not sure what the time unit is. But that's a little disappointing. So let's try it again. Let's try it again. Okay, so now it's 0:16. So I couldn't even measure the time that it took this time. Can anyone see why? Because the first time I loaded the assembly and did the jitting, which is part of the time that it took to do that method call. So now it's 0. I can't even measure it. But it's 16. I mean, who cares? It's still sort of the same. Let's do 15 instead. So now it's 359 in AX, but 15 in CIL. I mean, that's one order of magnitude improvement, right? Now, I can tell you that this gets more and more pathological as we go along. So let's make this 20 instead. So now it'll take a little longer, of course. La la la. Churning away, doing recursive method calls. There, we're done. So now, let's compare. So now we have 11,700 as opposed to 31. Now you can trust me, I can go on doing this. And the difference is going to get more and more pathological. Why? Because there is a big cost involved in doing X++ method calls. But that is almost free in .NET. So the Towers of Hanoi is 99% method calls. And that's why I took this example, because I wanted it to look really, really good. So I knew that that would be the case in this situation. So in this case, we're doing lots and lots of method calls where we shine in .NET. Of course, this is a pathological case. When you go out in your managed code or in your CIL code and do data access, you're still calling into our data access layer, which is the same as it has always been. So you won't get any advantage there. But for all the algorithmic content that you're doing, you will get a huge performance. How many orders of magnitude is this? I don't know. I can't even count it. 6 or something. In fact, I can get you any number there, and I can give you the order of magnitude that you want just by increasing this number. So I am unfortunately out of time at this point, but that's good because this was sort of the last thing that I wanted to show. I'll get back to you in a minute, sir. So this was my last demo, but I will just take the opportunity to do one more little thing. These are the results and benefits, right? So in summary, what we want to do, what we as a team wanted to accomplish was this. We had our two little sandboxes. We had our X++ sandbox, and we had our .NET sandbox. And they were sort of different. They were two different ones. You could go from one to the other, but it was not all very well understood and not very easy to do. Our aspiration is this. We want one huge beach full of people using our stuff and having fun while doing it. That's our aspiration. That's where we want to be. So with those words, I will end this session, and I will take a few questions. So please move up to the microphones to do so. And by the way, before you all leave, there is placed on strategic chairs, there is a Visual Studio 2010 evaluation version. Grab it while it's hot. It's a really cool giveaway. If there are none there, then go down to the expo at the Microsoft stand and grab them from there. All right, sir.
Yeah. My question is, though technically it's possible now to deliver just compiled DLLs, right? There would be no chances we will get in the future code from customizations, right?
Hang on. And fill out the customization forms. Okay, so the question was customization of managed code?
Yeah, for example, vendor will build whatever this vertical, right, and deliver only assemblies.
Yeah.
So we would never see even code, right? We cannot debug it if I'm doing only maintenance on the system.
So the managed code, as you perhaps saw, is part of the AOT. So that's why it'll work in layers as well. So if you have something where you want to customize a solution in AX, you just go ahead and do that, just as if it were written in X++. The solution can live in its own layer, just like you're used to. So that story is not correct. Whenever you do a build in your particular layer, it'll do the right thing. That's how it works. Correct. Well, I mean, the chances are that any sort of development that you're going to be doing in managed code will rely heavily on X++ code also. I'm not sure I see the... Well, I mean, the DLLs were, okay, if you're not giving the customer the model, then you're not giving him his value, right? Because that's where the source is. The source is stored in the AX model, along with everything else. Here. Somewhere. Come on. Right.
Your customization's gone if you recompile it.
A lot of the developers
About?
They're dealing with authenticating their code, so they're thinking that, okay, I deliver this to the customer, they can see the code in plain sight, then they can take that and we get into this infringement, because now the customer, another consultant comes in and is able to see that code in clear text, which he spent all of his dollars in technology and getting that to ship, and to the other consultant coming in, he gets that at zero cost. If they introduce technology,
Certainly, but that's the case in X++ today. So yeah, I understand. But you could do that in AX 2009 as well. You could do your business logic in an assembly, add it to your references node, and then make sure that it's installed on all the servers and boxes, and then you'd have the same thing. Then nobody would know about the code, you would only ship the result. This is a better solution because now we have it integrated, the whole build thing is integrated in the AOT. It's a step forward, not backwards. You've been able to do this, and you still can. You can still build your stuff outside of the AOT and use the old-fashioned business connector functionality, and then you'll be fine. And the customer will not see the code, and he's screwed if he wants to make updates to it. Yes? True. Yes, you can, because you can just open the But then then the customer doesn't have the value that you built for him. Because normally you would have this guy in here and you can do edit, right? And whenever you edit, you will start your Visual Studio and you'll be fine. It opens with all the source code and everything there. It's just as if it were X++. It's a complete extension of the X++ story. No more and no less, as far as I can see, if I understood the problem correctly. Anyway, other questions? Sir?
Speak a little bit to the security context crossing the boundary, especially from the server where you have the mixture of the service account, the user you're working on behalf of, and just speak a little bit to what is the actual network context if you're in the managed world, so that we can just have a sense for what we might run into.
So the model that we built is that that the managed code is a real extension of the X++. So you have no other security constraints than the ones that are active in X++. And all this is in proc, remember. It runs in the same process. So I don't see any network issues that could arise.
I'll get up here. You could remote out of the AOS to a WCF service, and there's got to be a security context on that remote out.
Certainly.
So it's really, what's the network security context when you remote out?
That question I will have to defer to somebody who knows, which is not me. The services guys will be able to give you a much better answer than I can, I'm afraid. I will not attempt to answer it. I'll be wrong. Sir?
Since you're, let's see, I don't know if this works. Yeah, since you're already generating IL, had there been consideration to actually merge from your solutions, from your .NET solutions, so you have compiler optimization opportunities rather than crossing assembly boundaries?
Yes. We have all sorts of optimizations that we can make to make this more streamlined, but we only, we have the resources that we have for any particular one release. Yeah. But we certainly have put ourselves in a strong position for the next one, right? And we're going to do tons of stuff like you suggest, and where you can just take the generated assembly that we have, add it as a reference to your existing Visual Studio project, and then go party with it. And all that stuff you can do already today, but we don't support it. But you can do that today. But we're going to streamline that story a lot in the coming releases and sub-releases.
So there's all kinds of opportunity for us to abuse this if we'd like to.
Absolutely.
All right, thanks.
Okay, let's stop this session now. You have lunch to go to. Thank you.